Let's take a look at how to connect Tableau to a couple of different data source types. There are many different types of sources that Tableau can connect to, broken down roughly between files and servers. Within files, you have a whole host of different file types that can be loaded as data sources, including Microsoft Excel, JSON, PDF. Let's start with a text file. And within this form, you can see the different file extensions that are considered to be text files by Tableau. This includes TXT, CSV, tab, etc. You can narrow it down by filtering just for those particular file extensions, or you can leave it as all compatible text file extensions. Let's use our Amazon bestsellers from last week's lesson and load that CSV file into Tableau as a data source. As soon as we do this, it pops open to this window in which we can see the different columns available in our data set, which should be familiar from last week. Within this, we can, if we choose, change the sort order in which it's displaying based on whatever field. There's a prompt for us to go to a worksheet, and that's the area in which we would create our visualizations and also create calculated fields for them. For example, if we go here, we'll see this looks very much like the pivot table creation screen that we saw in the Google Sheets program. We have options for sections for dropping fields into columns and rows, and over here on the right we have a whole list of visualization types, all of which are currently grayed out because we have no data at the moment. But when you mouse over each one of them, you will see the name of it: text table, heat map, highlight table, and so on. And within each one also a suggestion down below here for which particular types of data to choose for this. For example, for symbol maps, try 1 geographic dimension, 0 or more dimensions, 0 to 2 measures. I'll talk in a moment about what dimensions and measures mean, and also what the difference between the blue and the green signifies. Here, for example, is pie chart, and the suggestion there is 1 or more blue dimensions and 1 or more green measures, and so on and so on. But until we have some data, it's kind of a moot point. So what we have available to drop into our rows and columns are the fields from our source data. You can click back here to review the source data, and I can scroll through the actual values to see what the ranges are and representative samples are. Let's say, for the sake of argument, I want to put the category field into my list of rows, so that one row in each one row will represent one unique category. You see, there's only 7 unique categories here: books through video games, as we know. For our columns, let's say I want to display information on price, rating, and so on. What I can do is, could just drag price over into columns, but let's see what happens when I do that. It takes me into a bar graph, and instead of seeing price, what I'm actually seeing is the sum of price, which is what Tableau interpreted me to be asking for. And that is actually useful. Clicking on the down triangle allows me to see information about this calculated field. Notice there are 2 bullet points here that are mutually exclusive: discrete versus continuous. This is what those colors represent. Now this one is green, and you'll see that it's marked as continuous. The difference between a continuous value and a discrete value is that continuous values are assumed to be infinite. That is to say, there is no limit to the total number of values that could be included here. And things like price or date are basically like number line values. We can assume that there's no maximum price that will ever be enforced, no minimum price. So these could stretch out presumably to an infinite number of variations, as opposed to a discrete list, which is finite. You'll notice that my sum of price, when I selected that, changed from green to blue. That means there are now a discrete list of possible prices. We'll change that back to a continuous value. Now, the difference between dimensions and measures is basically the data type. You'll notice that these text fields from our data, the category, product link, and so on, these values are considered to be dimensions. As opposed to these numbers, price, rating, and so on, these numeric values are considered to be measures. These measures like this are coming up in green, showing that they are continuous, but the fact is there is nothing that limits measures to being continuous and dimensions from being discrete. Either can be either one. We can have discrete dimensions as well as continuous dimensions. We can have discrete measures as well as continuous measures. It really depends on how you've got it configured. But that's the distinction between the two. And right now, this calculated sum of price is considered to be a continuous aggregate measure. Viewing that as simple text table allows us to see the actual values themselves. So that's nice. We've seen the basics of loading data from a file and creating visualizations from that data, dragging values into rows and columns. There's more to it than that, but before I go any further into any more depth on that, let's look at a different way to load data. Let's say we wanted to change our data source. I'm going to remove this from my data source by clicking the down triangle, remove, and now there's nothing there. New data source. Again, I have a choice between different file types, but I also have a choice between different servers down here. And clicking the more gives us the more comprehensive list of different server types that Tableau is ready to connect to. And as you can see, it's a very widespread list of different database products. Notably, we'll find Microsoft SQL Server, which is what we're going to be using, as well as Oracle down here. You might recognize other favorites like PostgreSQL. I think we'll probably find MySQL and so on. We're going to use Microsoft SQL Server, which also shows up on my short list here. Within Microsoft SQL Server, there are some general server settings, and if you have used this before, as I have done recently, these will still be filled out. The server I'm going to connect to is the one that we use here at PCC. And if you've taken CIS 275 here, you should be familiar with this server. That's cisdbss.pcc.edu. CIS as in Computer Information Systems, DB as in Database, SS as in SQL Server. I'm going to leave the specific database blank for now, and I'll choose that later manually. Authentication types can be set to either Windows authentication if the database system you're connecting to uses Windows authentication, or specific username and password, which is account-based authentication. That's what we're going to use here, because we are going to use the 275 student account, which I'm going to recycle from CIS 275. And if you took that course here at PCC, this will be a flashback. The username for that account is 275student, all lowercase. The password is also 275student, all lowercase. I'll attempt to sign in. Let's say I use the wrong password. If I sign in with the wrong password, I'll get this error, invalid username or password. Take off those extra characters. The correct password will allow me to sign in, and I'll immediately go back to the data source screen, as we see here. Now, at this point, I have no tables available to me because I haven't chosen a database yet. There are numerous databases on that server available to this account. And if I click the down triangle, you'll see a list of the ones that are accessible. I'm going to use IMDb. And the moment I choose it, Jump the gun there, sorry. The moment I choose it, I see a list of available tables for that database. If you recall, if you have taken 275 through PCC, there are about a dozen tables in this database, including the title basics table, which lists all of the movies and television shows, one row for each title. The name basics table, which lists all of the people associated with them, one row per name. And there are some intersection tables between those two, like title directors, which is an association table linking individual names with individual titles based on the relationship of the director, as well as title writers, that links the same two tables except with the relationship in which the person has written that corresponding title. Now, I can join tables together in this graphic editor by dragging a table like title basics over into this editor. And when I do, it shows up here as a rectangle with various options that I can, for example, if I put the wrong table in, I can remove this. I'm going to leave it where it is. And down below, as soon as that shows up, and when I have this highlighted, I see a list of each of the columns in that table. These two options here will allow me to switch between previewing the data source, and when I click Update Now, it will actually show me the contents of the table for each of these, and I can scroll down through all the different rows, versus managing metadata, which will basically, when I click it, basically just give me a list of the columns in the table, along with their a little bit of metadata. Notice that the data type here is automatically detected by Tableau, and it's simplified into this little symbol, ABC, for alphanumeric characters text, the pound sign for numeric data like start year and end year and total run minutes. And Tableau has been clever enough to detect that the isAdult column is a true/false value. You look at the source data again, you'll see the only values in that column are either the word false or the word true. And Tableau is clever enough to have figured out that that's going to be a Boolean true-false value. It's going to convert that data, those actual words, true or false, into Boolean values. Very nice. Now that's one table worth of data. But if I want to actually join tables together, what I need to do is drag another table over. So let's start with the title directors table, which is associated with the title basics table, because it's an association table that, as we will see when I drag over, and as soon as I get it in this window, before I even release the mouse, it creates a little line between the two tables. And when I let up on the mouse button, that line will persist, and what I'm looking at now is the edit relationship form. That is, the relationship is the line itself in my little entity relationship diagram above. That's really what that is. It's not a standard crow's foot notation ERD, but it is listing each of the entities in rectangles, and the lines connecting them are considered to be the relationships. Now, by default, this has automatically chosen a relationship connecting the tconst column, that is the title constant, which happens to be the primary key of title basics, with the tconst column in the other table in title directors. And as it happens, that is exactly the correct relationship. If I didn't get that correct here, if the names of the columns that I'm joining on didn't actually match, if this match was incorrect, I could edit that here by changing the matching column on each side. But it is working out correctly, so that was very intuitive. I'm going to stick with this relationship as it stands now. If I wanted to join on two or more column fields, if this was a composite primary key, for example, I could add another condition in the join, but I don't need to do that here. Interestingly enough, if I click the performance options below, I can see the detected and assumed cardinality of the relationship. Tableau has assumed that this is a one-to-many relationship, one on the side of title basics to many on the side of title directors. And that is, in fact, the correct cardinality for this relationship. One title can have many directors, or many, in this case, the title director's entity. One row in that table represents one association of a particular director with a particular title. So that is, in fact, a one-to-many relationship. If I wanted to change that, I would have options to do so here. But Tableau has been pretty good so far about correctly diagnosing the relationship between these two tables and the appropriate way to join them together. We can further refine our match with either some records or all records, but the defaults here are fine. So we'll just look at those performance options but not modify anything. Now, the relationship didn't need to be modified, so I'm just going to close this, and now we have two tables in our join at the top. Each one, as I highlight it, will show me the list of its columns, either in list format with the columns themselves, or a preview of the data. And I can do the same thing with title directors, which right now is showing me no data. When I click Update, it will load the rows from the table. And as you can see, the title constant column contains values that look like this: TT followed by, was it 7-digit number? Which is the same value we find in the title basics table as the primary key, the title constant. So far, so good. Now, the title directors association table has another column, nconst, and that's name constant, which is the primary key of the name basics table. So I need to join that one as well. And if I drag this over, again, there's a little relationship line which, depending on where I move this, will either attempt to link to the title basics table or, more correctly, to the title directors table. When I release this, it does a snap alignment, gives me the option to edit the relationship, which by default is matching the nconst in title directors to the nconst in name basics, which is the correct way to do it. And this should be a many-to-one relationship. I'm going to take a look here, and in fact, yes, we see many on the title director side again, and one on the name basics side. Name basics and title basics are our primary entities. Title directors, as noted, the relationship cardinality has been correctly detected between title basics, name basics, and the intersection table title directors. So we have a join now of 3 tables, and we have columns from all 3 of these tables accessible to us. One more table I'm going to add is the title genre table. And if you had the entity relationship diagram for this database, you would know that the title genre table is associated with the title basics table, linked by title constant, the tconst column. And again, the cardinality for this is detected as one-to-many, where the one side is the title basics table, where this is the primary key, and in the genre table, it's on the many side. Very good. Now, going over to the worksheet, we can see in this case now a breakdown. Instead of a single table from a file, we have individual database tables for each over here, broken down by table, and within each a list of the columns. These blue dimensions and the measures, the numeric measures, they tend to come up by default. The dimensions, the text fields, tend to come up by default as blue, which is discrete. They're coming up as, in this case, as blue, as discrete values, which is correct. Now that we have our data source created, I'm going to add a new worksheet. The old sheet is still associated with the previous data source. So Tableau is a little tricky like that for undoing things. You need to start from a fresh sheet to avoid dependency issues. Now, what we see here in our data section is a list of the individual database tables, name basics, title basics, and so on, and within each of these, the columns in that table. Unlike the previous example where we were loading a single file, which basically gave us a single grid of information, one table, now we have multiple tables, and within each one, access to the columns, each one of which has its metadata displayed here, the data type, whether it's alphanumeric or true-false. There should be dates in there. I don't think we have we have a start year, which is technically a date, but it's being interpreted as a numeric field, which is fine. What we can do is begin to create visualizations similarly as we did before. Let's say for the sake of argument we want to show genres. I'm going to drag the genre field to the left so that it now shows up in the list of rows. And we see here a discrete list of genres from action through Western, sorted alphabetically. Now let's say we wanted to display a calculated value for each one of these genres. How many shows are there in the title basics table? If we go to the title constant column, which is the primary key of title basics, and hit the down arrow, there is an option to create things. And one of the things we can create is a calculated field. And a create, essentially, in this case, an aggregate value, which is going to be a count of the total constant values. This is the name of the column on which I'm creating this calculated value. I'm going to rename the calculation from calculation 1 to total shows. In order to calculate this, if this section over here is not visible, you can click this little gray triangle to bring up that list. And these are lists of functions you can use in this calculation editor. And it's a pretty extensive list. And you'll find the usual suspects in here. If we want to find count, there is a count function. And clicking on this doesn't do anything yet, but it does give me a description of the function and an example of its execution. Returns the number of items in a group. Null values are not counted. Now, if I simply double-click count, it will open up in this window. It will appear here with open and closed parentheses, and the prompt beneath will tell me that there's an expression that needs to be counted. Now, the tconst value over here by default appears outside of that. But if I move that inside the parentheses, what you'll notice down here below, there's a little hint that says the calculation is valid. If I didn't have that correct, it would tell me the calculation contains errors. Clicking on this tells me syntax error. If I fix this, I didn't have to click anything, it automatically reevaluated the expression and tells me now that the calculation is valid. I'm going to click on Apply to create this total shows. If I hit OK, then that would close this window. Clicking Apply leaves it open so that if I choose to make changes to it, I can. But the minute I click Apply, you will see that it does show up. Total shows will now be available down here at the bottom as an available field for my visualization. I don't need to do anything else with this, so I'm just hit OK. I will hit OK and close this. Now, if I want to add this to my columns, I can click and drag either here to release it or up in columns itself. I'll click over here and I'll highlight where it says Show Me. Releasing that takes a moment because in this case, this is a very large query. There are many, many rows in these tables. It did come back with a breakdown, and my visualization defaulted to text table. I now see this breakdown in text format with each genre value and with each calculated count of total rows for that genre. From here, note that a number of other visualizations are no longer grayed out. They are now available for me to choose. For example, horizontal bars. If I click this, the visualization changes to a horizontal bar format, showing the range of these numbers in bar format, which is useful. I could also try heat map, which shows basically the same breakdown except with different sizes of square. More useful, I think, would be packed bubble, the one down here in the bottom right, which shows me for each of the genres the size of a circle representing the relative number of total shows that that genre belongs to. Drama and comedy are the major players, and clicking on one of them in this visualization highlights it and shows me the total value, 1.1 million, so on. So this is a basic overview of how to load data from an SQL Server database and use this graphic format, this graphic interface, to join tables together. And if I wanted to add, for example, an additional where clause condition, there's a section up here in the upper right called filters. Let's say this data set is too big. I want to limit it to just the shows from the 1980s. I'm going to click on the add to add a new filter. I will click add again, and I can base my filter in this case on the, let's say, start year, the year that this show started. And the type of filter, I'm going to use a range because this is going to be the ones from just the 1980s. So I want one whose minimum value is not 1874. This is the lowest value of the existing start date, and 2115 is the highest. That's I think it's going to be a data error because we haven't had shows that go that far in the future yet. But there were some films that dated back to the 19th century. In this case, I'm going to use the slide bar to move this up to 1980. And when I get sick of using the slide bar, I can simply use the highlight the value and say 1989. Hitting tab narrows the little field, my filter field, to that range. Do I want to include null values? No, I do not, so I'm going to leave this unchecked. There are also filter options for at least, at most, and special. I won't go into those, but you can make an educated guess at what these are, how these would be applied, and feel free to play around. Right now, clicking OK now changes the detailed description of my filter to ranges from 1980 to 1989. Clicking OK will apply that. Clicking Update Now will show me the data again. Going back to my sheet, notice that the fields values have changed. We still have comedy and drama as the major players, but now the numbers reflected in these are much narrower. I'm only looking at 73,000 dramas instead of 1.1 million because my data are limited to that range. Now, this is an illustration of the ways you can join tables together, as I say, in this graphic editing environment and apply additional filters this way. Let's say, for the sake of argument, you have a more complicated data calculation you want to display. Let's say we're working with the IMDb data set, and we take a flashback to Lab 6 from CIS 275, and we had a query we've written that identifies the names of people who've directed more than 5 of the highest rated shows, and for each one of them we display the total number of shows they have written based on how many they have directed. That's a relatively complicated SQL calculation, and I could, if I were brave and intrepid and very tenacious, I could attempt to duplicate that logic in this graphic editor. But instead of this, I'm just going to start over. I'm going to remove everything. Remove. I'm going to add a new data source. I'm still connected to the SQL Server machine, but I'm going to drag this new custom SQL over into the Drag Tables Here section. When I do, it pops up with a nice big editor field saying Edit Custom SQL. Now, if I have already written some SQL, I can copy and paste it into here. This is the names of people who have directed more than 5 highest rated shows, blah, 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 and displaying and so on and so on. Here is the SQL query that solves that issue. Now, can I assume that everything is okay with that query? I know that it ran just fine in SQL Server Management Studio, so it is a valid SQL query. But within Tableau, I need to verify that it's viable. So what I do is I click Preview Results, and if there are errors, they will pop up here, like this. And as it happens, this ODBC driver is telling me the order by clause is invalid here. I cannot use the order by. In this tool, the sorting is done internally. This is similar to most or many reporting tools, Crystal Reports, that sort of thing. You want to do the heavy lifting of processing data within the tool itself rather than within the SQL. So, in order to make this query work, I have to remove the order by clause. Simple enough. Again, click on Preview Results to ensure that the query is valid. Now I get a new error. And this one is telling me incorrect syntax near this, which is the semicolon. Fun fact, the SQL standard, which dates back to 1970, dictates that every SQL query should be terminated with a semicolon. Fun fact, many reporting tools do not like semicolons at the end of the SQL query. So we're sort of damned if we do and damned if we don't. But since we're working in Tableau, when in Rome, do as the Romans. So I'm going to remove the terminating semicolon from my SQL query and click on Preview Results. This time I get no errors, and I do in fact get a preview of the output from this query. And just to review, what this query is doing is using a subquery to create a calculated value. And using that calculated value to limit the results based on the having clause, limit the results based on the return value, the calculated value, and from that create a list of names to be used in an outer query that doesn't look at the title directors table, but instead looks at the title writers table here. That's a relatively complicated query restriction, a query requirement. So doing this in SQL is a lot easier when you're working in an SQL environment. Once I've written that query, I can pretty much copy and paste in here without too much wrangling, other than what we've just been through. I click OK, and now we have a custom SQL query as our data source. It comes across as essentially one table, one entity in this diagram. And if I click Update, I can actually see the output. The primary name for each person, and for each of those, the total number of shows written. Now, these other columns, genre, this is left over. As I said, Tableau likes it if you start from scratch rather than mixing different data sources around. If you want to start with a new visualization, it's recommended not to begin with something you've already got and then modify it. It's better to start from scratch. So I'm just going to delete these leftover columns from my visualization. Now all I have is primary name and this field called total written, which if I want to review this SQL to get back to it, click the down triangle, click Edit Custom SQL Query, and there I have access once again to the SQL that I can manually modify. Okay, let's make a new sheet for this. And what we'll find, I'm going to use a new sheet for this. And what we'll find is that the available fields for our single data source are listed here. We see our primary name as the dimension, and then as the measure, we have total written, this numeric value. I can drag the primary name over into my rows list, drag the total written up into columns. By default, it has jumped to horizontal bar graph, which is a pretty decent choice of representation for this data set. I could instead list this as text table to see the values, or again, I'll jump down to packed bubbles, and we can see in a nice color-coded graph representation of the prolificacy of each of these writers, how many total title they have written, which can be drilled down for the individual totals. 478 for the largest, 180, 133, and so on. So, to review, the different types of data sources we have seen include loading from a flat file, like a CSV or Microsoft Excel spreadsheet, loading a data source from an SQL database using the graphic query joining tool, and lastly, creating a custom SQL query that's editable as code.